So we are going to dive into some of this stuff that we are having issues with. Part of that is breaking down radicals. Now again, we talked before about kind of our magic list of perfect squares here. And whenever you have a quiz or a test that has anything to do with solving with radicals, breaking down with radicals, any of that stuff, I think it's a good idea if you take a moment at the start of the quiz to jot this stuff down on the top of your paper. Because that way you kind of get a trigger in your brain of like, oh yeah, now square root of 72. No decimals. Oh, decimals. I wrote, decimals on some people's paper. I need two numbers. One of them has to be from this list, the bigger the better, that multiplies to 72. If that's not your strength, and for some of you it's not, and that's okay, here's what I'm going to suggest you do. I would take the 72, I would try some of these bigger numbers first, and just try dividing them in until you find one that works. Now if you get a decimal, okay, that didn't work. Let me try the next one out here. Okay, that one worked. I like this. So 36 and 2, or what, multiplies up to 72, but I'm not quite done. What is the square root of 36? 6. So the perfect square gets to break down, gets to get out of radical jail. The 2 is not in the list. It has to stay under. And that's all I'm doing. So for any of these, anybody want to take a shot at number 3 here? What can we multiply to get to 45, but one of the numbers is in my little list above? 9 and 5. Wow, got lots of you going here. This is good. Square root of 9 is 3. Square root of 5. Okay, I'm set. And again, if they're bigger numbers, play with it a little bit. Try some of the numbers out and find until you divide something in. So why is that important? Why would I want to figure out how that works? Because when we slide down a little bit, and we solve by taking square roots, I have two jobs here. Get x squared alone, or n squared, or whatever it happens to be. Okay. I take the square root, and then I have one more thing I'm going to remember. I always got to remember that I need plus minus with my answers. Why? Because that little 2, this is what's called a quadratic, and it just means there's 2 answers. But otherwise, I solve this like I would solve any equation. I want to get n squared alone. How do I get the minus 10 out of there? Add it. Once I get n squared alone, I can do the square root. Now, I always want to check to see if I can break the radical down. Sometimes I can, sometimes I can't. So if I look at this and I go, okay, let me get my list back down here a little bit. I don't know if any of these go into 46. Let's try some things out here. Does 16 go in? No. How about 9? No. 4? Okay, I'm not finding anything. So I guess that just stays under the radical, and that's my answer. And that can happen. Okay, they're not always going to break down, but a lot of times they are. If we do 9, it's basically the same idea. When I get down here, move this over here for a second. I can't divide first. It's always trying to isolate this first. Okay, once I get that term isolated, then I can divide. Once we finally get x squared by itself, I got to think about this for a minute. 27. Do any of the numbers in your list up top get into 27? Okay. 9 and 3. So you're like, okay, so x equals plus or minus. Square root of 9 is a perfect square. 3 gets out of radical jail. But the square root of 3 is not perfect. It's got to stay underneath. Okay, it's just some patience that we've got to take with these. Just kind of work it out, break it down that way. Oh boy, Harty. Then the fun starts. Factor completely. Eey. I wrote this on a lot of quizzes yesterday, so I'll write it here. Anything in common. Does anything divide into 24 and 54? 6. Okay. And x. Nicely done. I didn't even have to ask. They both have x, and I can divide a 6 in. So here's the part that, again, some of you are struggling with a little bit. This is okay. For the number part, I can just take this and divide it by 6. 24 divided by 6 would be 4. I've already got 1x. I need to get to 2, so I'll put one more in. 54 divided by 6 is 9, but I already have the x part. There's nothing squared here, because I know some of you might be looking and saying, ooh, it's a difference of squares, but this isn't squared. That's as far as I can go sometimes. But those are the types of things that I have to look for. So there's something in common, I should get that out. 13's the same idea. Okay, I get the easy part of the what's in common. I get the end part. 15 and 30. 15. And again, just use the calculator if you have to. 30 divided by 15 is 2. I got 1 in, I need another one. And 15 times what is 15? Well, 1 is. As far as I can go. Keep it simple. And you've got direct examples. That's the nice thing with this. You've got direct examples now for every single question as we're kind of working our way across. But life's about to get a little more complex. Oh boy. Nastiness here. Do those three terms have anything in common for 15? Ooh, no. Oh, Harty. Not only are you telling me that I need to slide and divide, that might be crazy enough as it is, but you gave me big numbers. Why you got to give me big numbers? Because I want us to see, at worst case scenario, what we're going to get stuck with here. So, okay, 54 and 7. Holy cow. Harty, you're out of your mind. I'm just going to skip this one. No. We're going to figure this out. So like we have before, we're going to take 378, and we are literally going to start dividing numbers in until we find something that works. But I'm not going to divide by 5 right away. Now again, I'm looking for two that are going to be 57 apart. So you're like, well, these small numbers aren't going to work. Can we start doing something a little bit bigger? Well, we could. We might miss something if we do that. But let's kind of keep playing here a bit. Now, did I put the wrong number? Oh my, what did I do that for? Oh, I see what I did. Silly man. I'm like, why'd that work? Okay, let's try that again. Thank you. That's better. Okay. So you keep playing with some of these, and you're like, okay, Harty, it's been like 30 seconds. The answer's not here yet. I want to quit. Not yet. Don't do it. Sometimes it will. So, oh, wait a minute. 6 and 63. Are they 57 apart? Yeah, if I'm not sure. 63 minus 57. Okay. Now I just got to figure out signs. Well, I want it to be negative 57. Okay. I'll make the 63 negative. That did not take that long. I wish I'd have been looking at my clock so I could have figured this out. X plus 6, x minus 63. Now am I done? Not quite. That first number I slid down, we're going to divide in. If it doesn't go nicely, I'm going to make sure it's reduced. Okay, it's reduced. So that'll swing back to the front. 63 divided by 7 is 9. Wow, I survived that one. You did. And that's as bad as it's going to get. It's not getting worse than that. I mean, a number that big, not going to happen very often, but if it does, we can do it. What if they're little shorties? Well, my clue, if they're little shorties, is coming back and looking at these and saying, hey, I recognize those because I'm actually starting to get used to them a little bit. So whatever I square to get each of those, square root of 9 is 3, x times x is x squared, 16 is 4, and then remember with difference of squares, it's 2 sets of parentheses, same values, but since I want the 16 to multiply to a negative, I got to have one of each sign. And I'm set. Don't make life harder than it has to be. And the only difference when we get below is when the word solve comes up, what does x equal? So when I get down here, I got to do my factoring still. So like if I get to 21, I still need to know what multiplies to negative 28. And if I'm not sure, remember, start playing with the calculator. If you're going to use it for something, we might as well get some good use out of it. Make my list of values that are there. And once I've made my list, look for the one that adds up to 3. Nope, 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 close, nope, yep. I didn't slide and divide, so I'm factored. And the only thing I've got left to do now is set each set of parentheses equal to 0 and solve the little mini equations. And I'm a happy camper. And that's going to be the same thing that's true with these all the way down. Now, be careful. Looking at this one, you're going, ooh, we're sliding and dividing again. But, do they all have anything in common? Does anything divide into 8 and 36 and 40? Bigger. Bigger than 2. 4. So you're like, okay, well, I take a 4 out, and so if I divide each of these by 4, you're like, well, what help did that do? I still got to do slide and divide. It didn't get me to like a diamond problem or something. That's true, but now instead of having 320 to deal with, where there's a lot of pairs of numbers, now it's going to be plain old 20. That's why it's important to always look and see, can I take something out? So once I slide the 10 down, I think we can do this without a list even. VV, multiply to a positive, add to a negative. Okay, negative and negative. Multiply to 20 and add to 9. And 5. Okay, but don't forget we did slide and divide, so don't set those equal to 0 and think you're done. Okay. And here's the cool thing about this problem. You're like, okay, 10 doesn't go into 4. I'm just going to slide it back. Don't do it. Make sure your fractions are reduced. Make sure with both of them they are reduced. Once they are, then I can slide them back. And I'm even going to show you one more trick. I'm all about keeping things simple. If you do slide and divide, here's the cool thing about slide and divide. When I get to this point, well, I'll show you this way. When I go to solve this, I want you to notice something, because this isn't just a chance that this happens, this actually happens. Watch what happens when I get both of my answers. Let's see if you see something, the same thing I do. You notice anything about what you got before you slid the 5 back and slid the 2 back in your answers? All you have to do to get to the answers is switch the sign. It was v minus 2/5. My answer is 2/5. V minus 1/2. My answer was 1/2. Okay, I still want to be able to do the factoring part, but as far as my answers go, if this is where you tend to make a mistake, that's a way you can shortcut it a little bit and actually get to an answer that's a little bit easier. But again, is it a process? Sure is. But it's one, again, that I know you can take care of. I know what you're capable of. All right, last one in the factoring arena for a little bit. Anything in common? Anything divide into 8 and 32? 8. X squared, 32 divided by 8 is 4. Check out what's left in the parentheses. How do I factor what's left in the parentheses? If you need to, look back up at number 17 as a helpful hint. Okay, right, what do we square to get each one? What do I times by itself to get x squared? X. What do I times by itself to get 4? Because it's a perfect square. 2. And since I want them to multiply to a negative, I do one of each type. Set each set of parentheses equal to 0. And get my solutions. So again, always looking to see if I can find something in common first to make it a little bit easier, or sometimes to be able to solve it at all. But factoring is something we've got to be able to do. All right. Oh boy. Story problems even, really, Harty? Yes. Because some of you got whacked for a big, huge, humongous 4 points on the quiz because you basically skipped it. So, here's what we got working. Area of a rectangle. Length times width. They give me the area, 55. They give me the length and the width. X times 2x plus 1. My job, work this out and find out what x is. So, we will first distribute our x through. 2x squared, not 3x, we're multiplying, plus 1x. In order to be able to factor these, it has to be equal to 0. So I'm going to minus the 55 over. You're like, oh, more slide and divide. Yes, because we are going to be factoring experts. I want you to think of factoring not as the bad F word, but like, well, fun's probably going a little too far. But, all right, so we're going to slide this down. I'm going to work over here. So I got x squared plus 1x minus 110. And you know exactly what I'm going to tell you we're doing. 110. I'm even going to help out with some of these to make us go a little bit quicker now, because you know what we've got to do, and there actually weren't that many to play with. Now you're like, well, none of those add up to 1, but remember, It's negative 110. So which pair of these subtract to get 1? This one does, if I put a negative on the 10. Remember, I did slide and divide. That's why I like to box that number so I remember. We're almost there. Some of you are like, holy cow, man. Should have given us more room. That I do agree with. And then I set those each equal to 0 and find my two answers. Now here's the kicker. Because when I set them equal, those are the two answers I get. Remember, we're talking about dimensions of a shape. Negative numbers make no sense. So my answer is x equals 5. When it asks for the dimensions, it just means plug x in. Plug it in. X equals 5. Okay. 2 times 5 plus 1 is 11. Okay. So 5 by 11. I'm done. Again, work? Yes. Impossible? Not so much. And then our last app from this sheet, because the other one we're just going to do a little repeat of some things. Okay, we're going to go down to 3 here. Egg is dropped from a height of 120 feet. How long does it take for the egg to drop to the ground? Okay. Where I end up, the ground, last I would check, that's 0. And this is going to be where I start. In this case, looks like a height of 120 feet. So 0 equals negative 16t squared plus 120. And I need to figure out what t is. So I do my thing. I become more of an equation expert because that's what it takes to be successful. And yes, I'm allowed to do decimals on this because, well, this is an application problem. People don't go around talking in fractions. So I'm going to find, once I move my calculator out of the way, the square root of 120 divided by 16. So it's going to take about 2.74 seconds for that to work. The only different thing that'll change in all these problems as we're doing them is the start number. This is going to keep being 0. I just got to keep doing the same thing. Okay. So for kind of a relaxation here a little bit, to kind of get some frustration out, that back page, yeah, no, that can go away. Okay. And then the only thing left here on what we're doing throughout the rest of these is we're just doing some more things with the roots. Now again, nothing incredibly crazy. I'm even going to, well, yeah. I'm going to do number 3. There's a couple of hand-picked ones I want to do with you here. Number 3, okay? Got to get n squared alone first. Again, no decimals here. No decimals. Nope, 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 nope. You're like, I really can't do a decimal? I'm like, no, and here's why. When you get to this part, let's think about this for a second. What's the square root of 4? What's the square root of 49? See, everything worked out nice. So if you get a fraction, a lot of times they're going to break down and come a nice number anyway. So it's not like it's going to be something that's, you know, terribly awful that I have to deal with. Now, will we get into some situations maybe, like maybe on the back of this sheet, something like 13. You're like, why does that look different? That doesn't look much different from the last one you did. Or the ones we did on the last sheet. Just a reminder, just because they don't come out nice right away Okay, it didn't come out nice. 75 is not a perfect square. Are there two numbers, though, I could multiply, one being a perfect square, where I could break this down? Okay, 25 and 3. Always have that list ready. Square root of 25 is 5. 3 stays underneath. I'm good. That can happen sometimes. And what's left on the rest of this, and again, we're just doing evens, so no panics here. On that last sheet, remember with these, this is always going to be 0, and this number is just where you start, just like we were talking about on the last sheet we were doing. No panics. And I'll even go one step further to make sure I help you out. On the back page of this, and then I'll flip back here, I had you do more rectangle problems, but I didn't label the sides. That was kind of not nice of me. So I will help by labeling the sides of the rectangles for you. Oh, actually, you don't need number 1, do you? Hee hee. Okay, so these will be like that last one we did. So again, x plus 2 is my length, x is my width for number 2. And when you get to number 4, oh boy, Harty did a crazy thing. I didn't leave your width as just an x number. I made it 2x minus 4. Okay, so for number 2, x plus 2 and x are my sides. For number 4, 2x minus 4 and x are going to be my sides. Your job is to crank through these evens. Again, if you're going to do a retake, I need to see them done. If you struggle on something, maybe go back and look at another example. Look at the examples you've got on the sheets themselves. Maybe go back and look at something like the quiz preview or something like that to get some more examples. We'll get answers up tomorrow. We'll talk about it a little bit, and then we're going to start our next section, which I believe in here is on imaginary numbers. You're like, really? Real numbers are hard enough. Imaginary ones, yes. So